Hello.
Sir, shall we start the session?
Yeah, you can proceed.
Okay, okay. All the participants mute yourself, Amma. All the participants mute yourself, Amma. Okay, Amma. Good morning to all. We are going to start the last day morning session. The speaker for this session is Dr. A. Kumar, Professor, Department of Mechanical Engineering, NIT Warangal. The highlighted points about the speaker are Dr. A. Kumar sir has completed his PhD from Usmania University, Hyderabad in the year 2008. Dr. A. Kumar sir has published 83 papers in various international journals, 70 papers in various international conferences. Under his supervision, up to now 12 PhDs are awarded and 6 are in progress. Up to now 27 MTech projects are completed. SAR has delivered 13 expert lectures at various FDP and workshops. Dr. A. Kumar sir has completed up to now 5 research projects and 2 research projects are ongoing. Sir has some awards on his name like Research Award at NIT Warangal in 2019, Best Teacher Award at NIT Warangal in 2019, in 2018 IIM SAIL Gold Medal and Distinguished Alumnus Award at Kakatiya Institute of Technology Warangal in 2019. Dr. A. Kumar sir is also one of the reviewers of journals like International Journal Advanced Manufacturing Technology, Material Science Engineering, Journal of Materials Research and Technology, Indian Journal of Engineering and Material Science, and Materials and Design. Now I request, this is a brief profile of the sir. Now I request the sir to take up the further proceedings. Welcome, sir. Dr. A. Kumar, sir. Welcome, sir.
Yeah, thank you, Srinivas Reddy. Yeah. Yeah. A very good morning to you all. First of all, I'll congratulate both the departments of mechanical engineering and computer science engineering for conducting 1 week faculty development program on machine learning applications for mechanical engineering. This is very hot topic today. People are getting FDP programs on this and 3D printing, and you can also learn things from the FDP program. So today my topic is on machine learning in resistance spot welding. This is one of my scholar who has completed PDF in South Korea. Same work I am going to present before you. Uh, uh,
Sir, just make it to full screen now, sir.
yeah, I'll do that. Yeah, it's okay.
Okay, sir. Okay, sir.
So basically, I want to tell you about the part to the participants is that whenever you are using any algorithms or any optimization techniques, without knowing the basic knowledge of the particular topic, it is very difficult to analyze the data. You are getting the results, okay, by giving input and getting the output, and you don't know the relation between input and output, how the parameter is affecting on the particular performance is most important. So once you know the basics of any process, then you can understand very well about the uh, any algorithms or any techniques or any fundamental issues. So before going to this, once you apply machine learning in any field, not only mechanical engineering, now people are working in different fields. It is a subset of artificial intelligence. So once you train the data to the machine, then machine will guide you in future aspects. So how you are developing the data, how you are interpreting the data to the performance is most important. So unless you can have a perfect interpretation between the input and output, then only you can get the beautiful results without any deviation from the expected values. Uh, yeah, my outline as speech is introduction to the resistance spot welding and the quality of resistance spot welding, a need for monitoring data and response surface welding monitoring and control systems, need of optimization conditions, and yeah, this is introduction to machine learning, then machine learning algorithms and case study. So this is the resistance spot welding. Looks like very simple. Why we need machine learning in resistance spot welding? It is only the basically your welded two sheets, which is normally used in automobile applications. So every automobile it requires some 3,000 to 5,000 welds are required. Once you make a weld, then it changes the properties of the material and metallurgical aspects also you want to see for the welded portion. So based on that, you can define the strength of the sheet. You can see the basic picture between the uh, two electrodes. You want to join the two materials by resistance spot welding. So the electrode is tip and bottom electrode. Then these two electrodes are connected to power supply. Then there will be a resistance between the two plates. Then you can decrease the resistance by supplying the heat in the form of heat energy. That heat energy is utilized to melting the nugget portion that is between the two sheets so that you can apply the pressure so that the joint is formed. This is the basic principle of resistance bonding. This is semi-solid in between solid and uh, liquid phase welding process, semi-solid welding process. Both heat and pressure can be applied in resistance spot welding. Uh, then how to judge your quality of resistance spot welds based on the kinematics and mechanic and dynamic mechanic machine properties, continuum mechanics, elastic and plastic deformation, and fluid dynamics because you are melting the material and apply the pressure between the two plates so that the material will flow in particular direction. Then you can see the how the flow characteristics of the material during the resistance spot welding. Then thermodynamics, because heat is involved in the process, how heat is affecting the material properties as well as electrode and other areas. Then electrodynamics, you are changing the resistance by applying the heat. Sometimes you can have constant resistance, current distribution, and what is the Joule effect. How heat is generated in resistance part welding is H is equal to I square RT. I is the current and R is the resistance and T is the time for supplying the current. Based on that, heat is generated. So when resistance is very high, then heat is generated high and current also high, then heat is also high. So based on these three input parameters, you can get how much amount of heat is required for a particular thickness of the material to be welded through resistance spot welding process. Then thermoelectric effect, filter and Seebeck and Thomson effect. This reference is then how to judge your quality of the resistance spot welding. You can see the cross section of the weld microstructure in between the two plates because the material is melted. Partially material is melted, not fully material. So only partial is in between the two sheets. There was some amount of material is melted, and you can apply the pressure so that the weld is solidified during the period of time. Then this nugget width and indentation depth and because of the heat is involved in the process, the heat is transferred to the other portion of the weld region. Then you can have a heat affected zone. This is a very dangerous zone compared to the fission zone because it alters the mechanical properties once heat is transferred to the surrounding material. So the weld nugget width is weld diameter and weld size and bottom diameter. So this weld nugget geometry, then need for monitoring data, the complexity in basic process that is resistance spot welding and complicated interactions between the uh, input parameters and material properties and input conditions of the process so that we can have a lot of interaction between among the variables. Then process conditions such as electrode wear, because you are doing multiple welds at a over a period of time. Due to that, heat is accumulated at the interface of the sheet and the work material. Anyhow, you are applying the pressure. Due to that, heat is accumulated over a period of time so that the material degradation takes place. Then wear of the electrode takes place during the process. Then work is split up and water cooling rate because you are circulating the water because of to reduce the heat accumulation in the electrode material. Then machine compliance because you are applying the force and other parameters, then what is the compliance of the machine. Then electric current and voltage displacement and dynamic resistance signals because you are supplying the current and voltage during the process so that heat is generated. So that heat is utilized to melting the two adjacent materials. So from that, what is the resistance you are going to change from the start of the weld to the end of the weld? That is known as one cycle. Within one cycle, how resistance is going to change. So based on the resistance, you can define the quality of the weld. So this quality of the weld, we can say the function of dynamic resistance. So the RSW here afterwards, I'm abbreviated as the resistance spot welding is known as RSW, monitoring and control systems. So welding system, this you can have a welding schedules and monitoring system, how to monitor the entire data through DAQ and signal processing, and control unit take care of all diagnostics and signal control. The DAQ electrode voltage and welding current, how much welding current you are supplying through in a cycle. Is there any variation during the cycle based on the resistance is going to change? Then how much force is you are applying? Then what is the electrode displacement? Because every time it may not be aligned with the bottom of the electrode, it may changes the alignment. Due to that, there will be change in the nugget growth process. The electrode tip voltage and current will give the how much of heat input during the process. Suppose if you are applying this less amount of heat than required, then weld nugget is not formed. If it is more than that, it is expulsion takes place during the process. So these are the two bad effects A low and high heat input will give the resulted in expulsion, as well as nugget is not formed. Due to that, the weld is failure. Then apart from the heat is accumulated during a period of time, that expansion of the material, because material should have electrical conductivity and thermal conductivity, then expansion takes place, then melting and expulsion because of the electrode displacement and force. Then dynamic resistance is a measure of electrical resistance change during the welding, calculated from electrode tip voltage and current. That is depends on your supplying the voltage and the current. You can also get the dynamic resistance. Yeah, this is the basic information about the process. What are the problems we are encountered during the process? Let us see the in the right side of the slide, the condition control. The first category is welding method. The second category, welding conditions, and subcategory current applied, pressure, and welding time. Then equipment wise, the welding gun, there is a misalignment between the two electrodes. That is shift the axis from one exact plane to the other area. So that leads to inconsistent heat generation during the process. Then shape the tip end. The tip end may going to change the shape, that will give the change in the resistance, so that the heat generation is also variation takes place. Then welding positions. Suppose if you want to weld at the end, then you can also see the what is the minimum distance you are leaving before the end of the component. That is also important. Then angle misalignment. Not only sometimes you are going to weld an angle, particular angle, that angle as alignment should be there or not, then you have to check. Then reference to the workpiece sheet assembly, sheet metal thickness ratio is also going to affect the heat generation of individual plate. And shape, sheet gap. Suppose if you have any uh, misalignment between the two sheets, so there is air is occupied between the two sheets. That air is a bad conductor of electricity, so heat is not transferred to the location. That's why sufficient amount of heat is not generated, because Joule effect is reduced, that is H is equal to I square RT. I is going to change, then there will be a problem for. So this construction of fully reliable resistance spot welding, Tata Motor Corporation. The welding current in the left side, applied pressure and welding time, and tip misalignment, tip end diameter, tip end curvature, edge welding, angle misalignment, sheet metal thickness ratio, sheet gap. So as far as if the project is concerned, either BTech level or MTech level or master's level, without applying the machine learning algorithm, only we have to take only few, 3 or 4 parameters. For example, welding current, apply pressure, welding time, and sometimes we can also take angle misalignment and sheet metal thickness ratio and sheet gap. Based on that, we are giving input parameters so that we can get some output in the form of a nugget area. So input condition and output condition, there should be a relation between these two by using statistical regressional analysis. From that, we are expected the result, that is outcome of your nugget diameter or shear strength of the welded joint, so that it will give only 80 to 90% of the accurate results. But nowadays, people are not accepting this 80 to 85% of the response, because you are ultimately you are going to entire things is to be automated. So even if it is small change in the parameter, so that will affect the entire system that will leads to a lot of loss is there in the company. That's why the people are not required. Exact requirement is required for the automation of the process. That's why you have to take up all the parameters which are involved in the process, end diameter, end curvature, and misalignment, and electrode material, and sheet gap also you should consider. Then we'll see the what is the need for optimization, what is the important aspects you are going to get for optimizing the results, uh, so that you can get the full automation of the entire process. So then you need to observe the dynamic resistance during the process, and electrode displacement and dynamic force. So these three things are important to analyze the data, and you can predict the data for any performance within the acceptable limit. So from this observation of the optimization, you can also get the produce the quality of the welds, and improve the welding schedule, and to reduce the cost by improving the electrode life and eliminating the fault conditions. Uh, so signal reflects electrode alignment and position along with the schedule. Now this is the dynamic resistance curve. You can see the dynamic resistance curve. Based on it, you can get the some more information about the input process. So here the in the y-axis is the resistance, and the x-axis the time. So that in a particular time that when one weld is completed, the one resistance part welding is completed. Suppose if you start supplying the electric current between the two sheets, then surface breakdown, that is surface, every material has its own surface energy. Once you are giving sufficient amount of energy, that energy will utilize to break the surface, so that the heat is conducted between the two materials. So at this point of junction, the surface breakdown, so that the resistance is coming down, then a material is going to very soft. Then at this particular position, you are getting the lower resistance. Then you are supplying the current and the time, so that the heat is generated, so that the heat resistance is also going to increase to a certain level. Then after melting, still it is increasing to reaches the maximum value. Then you are applying the pressure, because you are going to stop the supply of the current. Then you can apply the pressure, so that the nugget is formed. So then the resistance is going to change. Now if it is supplying the current more than the required one, because you are supplying the weld nugget portion is more than the required one, then whenever you are applying the force more than the required one, then expulsion of the weld takes place. So that curve is like this. If the dashed line is give you a better resistance spot welds, when it comes down, then you can say that this belongs to expulsion of the weld, that is a defective kind of weld material. Now, based on the RMS root mean square secondary current in terms of amps and the welding time cycle, this is the region is acceptable nugget area. Beyond that, you have expulsion of level, and before that, smaller or brittle nuggets that leads to a defect kind of welds. So you can see the various dynamic resistance, electrical parameters during spot welding of mild steel, resistance and current and voltage. So you can see the normal curve without any expulsion, that is with continuous line. This is the dynamic resistance curve. And you can see the voltage, you are going to supply the voltage up to maximum then we are going to decrease the level. Then similarly, you can current is decreased, and after that it is almost constant, so that you can understand very well about the dynamic resistance and voltage and current, so that you can able to correct get the relation between the input and output parameters. So this is number of cycles with respect to the how the nugget is formed. This is 2 cycles and 6 and 4 cycles and 12 cycles. So based on that, you are getting the data from the controller. You can get the resistance, how resistance is. As number of cycle is increasing, resistance curve is also going to change uh, depending upon uh, the number of cycles. Yeah, this is resistance spot welding video. Just you can see how the weld nugget is formed. Oh, the smaller portion is melted, and you can apply the pressure, then allowed to cool, so that this is black portion is the edged region, the orange color region is the nugget portion. So this diameter will define the your strength of the resistance spot welds. Yeah, based on this, just you can see observation about the welding current and the time cycles. Now, we are interested in this region because this is the acceptable welded condition. So that related to the curve is like this. This is the dynamic resistance curves. Then if it is expulsion, you are going to get this kind of curve. If it is brittle nugget, you are going to get this curve. So it looks like 1, 2, 3, and 4 looks like same, but it if you are observing keenly at high magnification level, there is a difference in the profile of the each and every parameter. Yeah, you can see the good weld and poor welds, how the resistance curve. The welding time versus resistance, yeah, this resistance is maximum. Before this maximum heat is generated, you are supplying the current and the time, so that the resistance is increasing up to this level. Then after that, it is going to decrease. This is this period nugget growths, and this period is heat generation. At the beginning of the current applications, this is the then nugget starts from this portion, and this portion, this nugget grows, and based on this you can able to get this kind of curves. So once the curve is like this, you are says you can say that this weld is a very good one without any defects. Now this second core portion, the poor welds, how the poor welds, they can see the R maximum somewhere, because it is generated more than the required one. That's why expulsion of the welds takes place. So that leads to defective kind of welds. Then machine learning algorithms require some characteristics data analysis, because you have to design the system with a very effective manner without any change in the uh, quality of the welds. Now, this is the dynamic resistance curve. The x-axis is the weld time or a weld cycle, and the y-axis is the welding resistance. Then, then what are the parameters that involve in particular shape of the curve? You can see you can define these variables. X1 is the height of the, that is R maximum. x1 is the height and x2 is the area under the curve. We'll also give some information about the rest and spot welding and what is the slope. X3 is the slope, it is in a positive direction, and x4 is the slope in negative direction. Then xy is the maximum value, and x6 the difference between initial and final value. What is the max difference between these? And x7 is the difference with the average initial. What is the average and what is the final value? And x is 8 is the difference with the average. So just you can see the curve. Based on the curve we can define all the parameters so that you can judge perfectly without any deviation from the uh, actual situation. Uh, so without defining all these things, all the curves looks like same, but you may not get the perfect data. So the maximum temperature, how much total heat generation, heating rate, nugget growth rate, conductivity of material, sheet thickness. These all 8 variables reflects all the variables, that is temperature, heat generation, heating rate, and growth rate, conductivity of material, and sheet thickness. So the x1 is maximum break less than greater than or equal to maximum temperature rise, and x2 greater equal to or greater than total heat input. X3 is the heating rate, and x4 is the negative growth rate. Xy beat peak information time more than equal to greater than delayed peak. Nugget growth time is gradual if more. Heating rate is more if possible. Resistance drop greater than or equal to surface breakdown if negative. X8 more than or equal to greater nugget growth and expulsion liquid. Yeah. So apart from this, the set two of experiment 16 characteristics instead of 8. You can also extend it to 16 characteristics. That 1 to 8 is the set one, and 9 the minimum time, that is alpha, is defined. Yeah, alpha, that is peak formation, that is nugget growth end. This X12, the positive, uh, this X12 is a positive general or root waveform or downward curve, and X40 is energy required for melting, and X16 maximum final slope greater than or equal to negative growth. So this is the general waveforms related to resistance spot welding. So the general one resistance, this is like this, and the second generation is like this, and third one is like this. And with respect to the welding time and resistance, uh, this fourth general and the fifth general, and it's also you can see the root waveform, welding time versus resistance, welding time, root 1, root 2, root 3. And sometimes you might also get platform because expulsion, during the expression, you can get this time. Then downward sloping waveforms, this is upward and this is downward. Slope 1, slope 2, slope 3, and slope 4. And this already you can define in the machine learning algorithms. Now, classical programming, it requires data. How much data is required for programming classical programs so that you can get the some defined answers. Then what are the rules that are required for the clustering algorithms? This machine learning now will come to the. So before these slides. First, you need to understand the system. From that system, how you are defining the variables, then what is the effect of each and every variable on the dynamic resistance curve, then Based on that, you can have some input data. From that input data given to the machine, and it will train and it will give output with effective manner. So then machine learning, what the data input vector x1, x2, x3, it's because we are defining the dynamic resistance curve from that x1, x2, x3. So indirectly, that dynamic resistance curve is depends upon the input variables like welding current, welding time, and resistance and material and shock. All the parameters are involved to get the dynamic resistance curve. So first what we have done is initially we have to give the input data of welding parameters and work parameters and tool parameters. From that, you can get the dynamic resistance curve. So from that dynamic resistance curve, we can analyze the data and will give the effective method of interpretation of the input and output variables. So you are giving some input to the machine learning. You are expected some output or targeted value. How much target is required? That also you can give the, as an input for the machine learning. That is maximum and minimum. So beyond that, we cannot go for the interpretation of the data. Either within the minimum and maximum level, we can work on this one. So the output diameter here, we can say the diameter of the nugget, how much diameter is required for a particular uh, weld, and how much strength of the welded joint is required for this one. Then what are the rules that are applied for getting these data and interpreting the data using machine learning algorithms? Then you can have a mapping with the input and output, and so that you can get some. Now it is in the form of a matrix 1 into n, and that is x1, x2, x3, x for variables, and the input vectors n into 1, then output vector, then you can get 1. So for accurate prediction of values, we have to identify the input vector for each waveform. For example, general one input vector is a function 1, x1, xy, x13, x14, x20, x24. So similarly for general 2 and general 3, general 4, you can identify which variable is more dominating with respect to the general 1 or 2 or etc. So need to be identified. Then you can give then what are the steps involved in machine learning algorithms. So initially you have to gather the data. So decide what data means is a part of the problem. The data is reflecting on your output parameters. So whatever the data is, whatever the data you are giving input to the machine learning algorithm, that is more important. And also you can have the data, more and more data will give the more accurate results. Then preparing the data, ensuring that there is no bias between these uh, three, four values, because during experimentation, suppose if you are giving one input conditions, and you can run the experiment more than 3 or 4 trials. So for example, if you are getting 4 trials, one value is 10, another value is 12, another value is 11, another value is 10.5, another value is 25. So three values are very closer, and the fourth one is away from your closer value. Then you can eliminate that fourth value for giving the input data for the machine learning algorithm, because there is some variation in the process that leads to uh, get the value other than the nearer to the your mean value. So the mean data is important. The mean nearest to mean data is very important to give the input to the any algorithm of machine learning, so that you can get the effective uh, relation between the input and output condition. You can also train the data effectively. So that is important. That is no bias between the taking the data of a number of points. Choosing a model or algorithm, random forset, and which algorithm you want to like to use for predicting the data. Random forset and artificial neural networks, hidden Markov models. Random forset because suppose, for example, you have a basket of different kind of fruits. So from that fruits, you are getting one apple. Apple is best. That is more than other than fruits. Apple is dominating in the basket, but you don't know. So randomly you are pick the some fruits from the basket, then you can separate into different categories. Then again you have to put the same the random samples into the basket. Again you have to take the random sample again, then again separate it. Like that you are differentiating in each and every segment of random sample. So finally, the best one is uh, the more number of uh, data points, that is more number of relate points related to the particular identity, that identity will give the best one. So this is randomly you are selecting the sample and you can separate it, and so that you can go for more iterations so that you can get the best sample from the random set. Then artificial neural network, you are giving the input data and you are getting the some output data. Then you want to find the relation between the input and output data. Sometimes regression analysis will not uh, get the relation between these two because the data is not continuous manner. For example, you have a variable of x, one is a one variable that range is, let us say, 10 to 15, you can work, but 10 to 12 is okay, but 12 to 13 we don't have any data, but 14 to 15 we have a data. So that means that the variable is a discrete one, not a continuous one. Then you cannot use a regression model for that. But we need to work, we need to get the relation between these. That in that case, ANN is most suitable for this problem. Whenever the discrete data, then you want to find relation between these two, then you can get this information. So there are each and every algorithm you have disadvantage and advantage. Out of this, you can use a best one, and you can utilize for any algorithms. Then once you choose the algorithm, you can train the data using the data to determine the model parameters. First of all, if you use ANN as a algorithm, you can train the network. So see that error between the your expected value and actual value will be very closer, that is less than 5%, so that you can train the data. That data is used for training the network, used for predicting the future one, that is so that you can give more weightage to the each and every layer that will give the best one, that W1 into one layer and W2 into another layer. Like that you are getting the different inputs. Then how to get the evaluation, how well did we do the test evaluation. The evaluation is very important. How to validate your this one your then you can, once you are getting the optimized condition, then you can validate your results. That validation is very important for getting the correct training of the data. Then hyperparameter, how to tuning the data. Suppose data is inconsistent in some cases, then you can tune the data as per your requirement or as per your model. Then prediction and deployment, how you are predicting the future for the performance based on the your algorithms. Then machine learning is I'm not going to detail because already many speakers are spoken on supervised and supervised. So then for mechanical engineering, we need to learn more on supervised learning because the property is available, that is valuable for certain data set, but is missing and needs to predict it for other instances. The that is quantitative values are available for that you can use machine supervised learning process here. The allocation of experiment to gives various waveforms, category, the welding method, yeah, uh, for example, low, mid, and high, depending upon your experience and depending upon the literature, you can give the uh, quantifying the data in terms of 1, 2, 3. So these are the dynamic resistance waveforms for good welds in the left side and bad welds or defective welds in the right side. So these are getting from the machine, automatic machines. So from that you are getting the dynamic resistance curve because they have performed the way number of welds. From that you are getting the uh, uh, good welds after characterization. Then based on that you are defining these curves are related to good welds. Yeah, judging by discriminant analysis, you can see the let us say current judgment rate is 80%. Discriminant analysis performed for 6,561 samples of good quality welds and defective welds. So judgment is okay because more number of quality welds towards top side, only few welds are going downwards, that is defective kind of welds. So the more data is towards that is clustering in a particular place, that will gives a good type of welds. Suppose if it is a judgment rate is more than 88%, then you can see the this judgment is okay and judgment is negative, so that you can get the uh, good quality. So from this group variable, good quality or defective welds, what are the, just you can yes or no. Then explanation variable, 8 characteristics value. Here he has given x1 is the height, x2 is the area, and x3 the slope, and x4 is the decreased slope, and xy is the maximum time, and x6 is the difference between initial and final value, and x7 is the difference with the average, and x8 is the difference. Whatever the variables which are going to measure without any deviation from the real pictures or real graphs, so that you can take 8 variables from that, you can get this kind of parameters. So for this case study, we are taken 2 sheets of similar one and 2 sheets of dissimilar kind of materials. So that will define the thickness ratio is thickness is 1.6 times the T thickness, and 1.6 both material thickness is same, but here dissimilar kind. The sheet thickness is different, 1.6 and 1.2, so that the total thickness of the entire nugget is to formed 3.2 and 3.2.8. The welding current is applied during the resistance fault welding, 8.6 kilo amperes, 7.7 kilo. Then welding cycle time 20 cycle and 18 cycles. Then how much force is required? 32 kg force and 340 kg force are required, because so these are the variables, that is minimum is 2.8 and maximum is 3.2, and here also 7.7 and 8.6, 18 and 20 and 340, 320 and 340 kg force. So this is the experimental layout, welding current, uh, applied pressure and welding time, and edge welding 0. And here you can also go with the 2 mm edge welding. Then angle misalignment 0 and alignment is 3. Intentionally, we are giving the 3 sheet metal thickness ratio 2.8, 3.2, and sheet gap between the gap you can see 0 and 3.2. So you can go with this is a two level experiments. There are 7 parameters. The 2 to power of 7, that minimum number of experiments required to run the process, it is 2 to power 7. 2 to power 7 is 128 experiments. So at least you have to run each experiment in 3 times, that is 3 times. 384 experiments are required for analyzing the data. So out of 384 experiments, you can also see whatever just now is given information about the biased data. If it is uh, three output parameters are nearer to each other, you can take average. If it is away from the average on any one of them, you can leave that one, and you can make it average again. So strength of the sample, and we need to conduct some more experiment for judge the strength of the sample for 108 experiment. So that totally you need to run the experiment 5 experiments, that you finally you are going to get strength and get diameter. So this machine learning or artificial intelligence, once you are applying the machine learning algorithm to any kind of field, first of all, you need to generate a lot of data. That data is useful for predicting the performance effectively. Yeah, variation of current, that current you are going to variation in the selected experimental layout, because this is experimental layout. Now you want to see the effect of current on the resistance curve. So 7.5 kilowatt, what is that, and 8.5. That we are going to see from this graph. So before this, as in the earlier slide, we are seeing the dynamic resistance curve. So categorized, you can convert into line segments. Uh, this is one line, another line, like that. From that, you can get the slope for x1, x2, x2, uh, and x5, x8, and the difference between these x4, x7, and x3, x2. X1 is 0. So like that, you can define uh, as input parameters in order to examine the variation of trend of the resistance, the standard deviation of the dynamic resistance x9, uh, and the standard deviation of the variation of per cycle in dynamic resistance x10 were used. So that Frobenius norm is the square root of all the output of the vectors. So this x1, x2, x3, x4, so many variables, the characteristics variables, then you can convert it to signal number, that is scalar vector, that is conversion of this. You can use Frobenius norm. Yeah, from that, just you can see the resistance values of different variables. You can get the different. From that, you can convert into Frobenius norm 519.71 from this row, and from this 522.8. Then you can draw the curve between the well time and dynamic resistance for 7.85 kilo amps and 8.5 kilo amps. So from that you are getting all these values. From that you can find out the what is Fibonacci now. So this is with reference to the variation of current from 7.5 to 8.5 kilo amps. So this red color will 7.5, and dark one is, or black one is related to 8.5 kiloamps. So welding current in the selected experimental layout, and you can see the yeah, 7.5 and 8.5 kilohertz. Then the sheet gap, what is the sheet gap between these? Uh, that is 0 and 3.2. So from this, what is the resistance, dynamic resistance curve? We are going to change, because if it is 0, red color is 0, it is like this. If it is 1, it is slightly changes in these some positions. From that, you are going to get 484 and 488. There will not be much change in the Frobenius norm, even if you change the gap. Then variation of welding time in the selected experimental lane, you are going to change the welding cycle time. So the RO1, the 20 cycles, RO9, that run order is 39, 18 cycles. Then you are going to get this kind of values. From that you are getting the Frobenius norm 484.94493. From that you are going to get this one. Then effect of electrode force in the selected experimental layout, because he has done a lot of experiment. From that he has selected the run order one related to 340 kilowatts, and run order 100 related to 320 kilo force, so that you are getting the different values of x3 x4 like that. So from that you are going to get the different dynamic resistance curve. From that you are going to select the 484.94 and 513.86. Then variation of sheet metal thickness in the selected experimental, because we are initially, I have shown you in the one of the slide, the variation of thickness between the two groups, 2.8 and 3.8, and also similar and dissimilar nature also. So not only difference in thickness, and it also similar kind of material and different kind of materials. Now, based on this, just you can see our run order 1 is 3.2 mm, and run order 26, 2.8 mm. Then there will be, you can observe, there will be change in the dynamic resistance curve. The blue one is reflected to 3.28 mm, and this one is reflected to uh, 2.8 mm. So 2.8 mm, just you have we observed the previous slides, it is dissimilar kind of materials. So if it is dissimilar kind of materials, the thermal and physical and mechanical properties are different. Then heat, thermal expansion or thermal conductivity is also different. That's why the failure expulsion takes place. That's why you are getting this type of curves. Then you can observe, just you can see there is a large variation in the Frobenius number. This is a 484. This is 624 or 26 value. So from this, you can see the observation of various Frobenius numbers, and based on this, you can see that this value reflected to expulsion. This is out of the region of your domain, and this also out of the region of your domain, because it is going to get the different kind of welds that leads to brittleness of the weld, so that the ductility is less. So this kind of welds, very good welds, that is Frobenius number. Yes, you can see the Frobenius number 400, 450, 451 to 500 is 2, and 5 not 1 to 5 like that. So from this Frobenius norm, we can differentiate in three regions. This the middle region will give the non-defective nature. So that Frobenius number related to less than uh, 550, that reflected to good welds or good quality welds. More than that or less than 400 also, it leads to defective kind of welds. So from this segment, so this automatically, the algorithm automatically will give this picture, so that from this is the region is the safe region, that is away from the region is unsafe and below the region is unsafe. The middle portion is the safest region. Suppose if I want to work on some other kind of materials, different similar materials but different thickness, different resistance. Suppose if I expected some Fibonacci number in particular value, so that you can get this information. So this is the principal component analysis, or we can expected the outcome in the form of x variables, that is x4, x4, x3, x4, and these are the coefficients x5, like x10, then this one, so that you can get some more information. You are going to get the in between the values. So sometimes in some cases, because yes, because Western spot welding is a very simple welding process, and also it takes very less time to complete each and every experiment, so that you can run more number of experiments. That is not a big issue. Suppose if in some other situations, suppose additive manufacturing process, suppose if you want to apply machine learning algorithm in additive manufacturing, if you run all 5 12 experiments, it takes a lot of time, and a lot of money is involved in this process for getting this data. So for that, we need to do some optimization techniques using some Taguchi and other uh, central composite design will be used to predict the equation, that is using principal component analysis. From that, you can predict the equation with reference to the input variables on some variable. From that, you can generate a lot of data in between the variable. For example, 10 to 20 is a variable, is ranging from 10 to 20. So I worked on only 10 and 20, but I don't have the data in between 10 to 20. But I have equation using the principal component analysis or some regressional analysis. From that, you can get the relation between the output and input, so that you can generate inter data between these x1, 11, 12, 13, 14, and so on, so that you can have more data without any much cost involved in the process, and also time, so that you can save the time. Some clustering analysis, you can see the clustering data. One says 200 set X1 and X2, and the methods of 4 different methods, and the classification into 2 groups, whether it's a bad or good, depending upon the data available. This will give automatically from the software. Then this is the cluster algorithm. So from that, you can able to judge which one will give the better results, which will not. Uh, then input rotation speed, feed rate. This is machine learning algorithm. Gaussian progress process regression, support vector machine, multilinear regression analysis. So normally we are working on multilinear regression analysis. Using that, we can apply regression. Uh, then we can get the some equation. Then we can use the machine learning algorithm. You can get the better judgment. Then sometimes, as I said, the central composite design, current, voltage, and travel speed. You can use central composite design and arc sound welds captured and statistical feature extraction. Then decision tree algorithm, random foresight algorithm. Then you can see the good welds, lack of fusion and burn through, like that. Then process condition tensile testation statistical feature extraction, particle swarm optimization, kernel extreme learning machine. You can principal component Kelm. You can get more information. This is already discovered. Then the strength, some data points from that you can able to judge which data points will give more performance. This weld strength versus resistance, maximum delta or ohm weld strength, and maximum or weld strength versus strength. Yeah, these are the experiments. Need to establish the interrelation between dynamic resistance curve and surface image and cross section. Then after that, you are going to see the actual scenario. This another trial one, trial two, see the 5.18, 5.29, 5.58. So what I'm trying to say is these two are very closer. This is away from this. Yes, you can take average of these results so that you can get the better one. So not only input variables which influence on the output parameters, it also some other noise factors that we can study in Taguchi and design of experiments. Some noise factors which are not controlled by you or in the process. So that will lead to variation in the results. So here 6.17, 6.27, 5.63. So 2 and 3 is very closer so that you can eliminate trial 1 for taking the average. So you can also do some simulation for getting the more data for analyzing the more effectively using machine learning algorithms. So this based on this, you can also draw the curve that will give the more information to the those who are working in this area. Workpiece wrapping with, so let's say one, the first condition wrapping, so that the resistance is going to vary with respect to the time. Then it's a normal condition. Then poor quality of the welds. Then electrode axial dislocation, which dotted one. Then this fifth one is electrode dislocation. Then surface contamination. Sometimes if you are not removing unwanted materials, then that contamination leads to decrease the uh, flow of current between the two sheets, that leads to decrease in the heat input to the process. This is again electrode displacement, electrode wear, adaptive controls. You can also monitoring and feedback signals so that automatically you are changing the input conditions. Then finally you are applying the artificial intelligence for performing the experiments using any uh, man intervention, so that these are the experimental setup which is available in uh, South Korea, because he has done a lot of work on this. Presently, he's working as a assistant professor in NIT Surat. Yeah, this is a dynamic resistance curve from the control panel. Yeah, this is a weld nugget portion. Yeah, yes, you can see the can also metallurgical aspects. You can also the temperature and various locations, so that phase diagrams, from the phase diagrams you can see. Yeah. So these are the open programs, features and applications of additive manufacturing. Then you have a lot of programs you can write your own code in any language, either MATLAB or Python. And already codes are available in the open source. Yes, you can take the code and you can utilize your facility, and you can give the input and get the uh, final judgment. Yeah, yeah. This is the predicted equations from this data. This node effect and defect area. From that, you can draw the line which separates the good data and bad data. From that, you can get 3D picture. From that you can get some equation which is nearer to this one. So this is the Wicker hardness number. Additively manufactured parts, different aluminums are given below. And also variation of the composition of additive manufacturing components. So from this Wicker hardness number will give some relation between these. So this equation will enhance, will give the information about the component hardness uh, is a function of all the elements. Thank you. So if you have any question, you can most welcome.
Sir, actually, they have posted some questions in chat box, sir.
Okay.
Uh, like one of the question is the list of dependent variables in this welding quality measurements experiment.
Yeah, dependent variables, welding current, welding voltage, and time and resistance. These are the dependent on resistance of the dynamic resistance of the curve.
Sir, another question is, sir, how can we reduce the runs and figure out the optimum input parameter if there are 4 input parameters with 3 levels?
Okay. You can use Taguchi method. You can use Taguchi method. From that, you can get better or bad kind of welds, and the latter you can apply to regression so that you can get some equation between the input and output variables. So from that you can predict n number of data from that equation. That data is useful for in machine learning algorithms.
And last question, sir, another question is there in the chat box. What are the different dependent and independent variables generally used in most of welding for measurement experiment?
So dependent, not dependent means, suppose for example, dependent variable is welding current, for example. So each and every machine has its own specifications. So dependent variable, suppose once you change the variable, it automatically changes its output characteristics curve. That is dependent variable. So non-dependent variable is suppose material property. For example, so if you take a dissimilar kind of materials. So in dissimilar kind of materials, the welding current and other is not depend on the properties of the dissimilar kind of materials. So from that,
Participants, if you are having still doubts, you can ask them. Participants, if you are having still doubts, you can ask. You can unmute and talk, Amma. You can unmute and talk.
Hello,
yeah, tell me.
sir. Good morning.
Good morning.
Yeah. So in this resistance welding, sir, suppose I have a poor, the input, input parameters which are affecting the weld quality. So how to identify, which one is, contributing more to the weld quality by using machine learning?
So that's why initially what I told is you have welding current and welding time and resistance. From that you are generating the dynamic resistance curve. You are getting the dynamic resistance curve. So once you have dynamic resistance curve, then you can after weld you can get the cross section. You can see the microstructure and you can see the inspection, visual inspection as well as microscopic observation. So from that you can say that with there is no defects or you can define the what is a weld nugget diameter and weld width and other quality of the weld nugget portion. So based on the literature, you can define this kind of diameter or this kind of width, this kind of microstructure related to good welds. So from that,
Okay.
you can judge whether it is a bad quality weld or good quality weld. So like that, you are performing experiments and you can do characterization. From that only, you can get this whether it is good or bad. So
Okay.
whatever the 512 runs, he has completed the welding as well as characterization.
Okay. Nice, sir. Thank you, sir. Thank you.
Fine.
So there is one another question in chat box. By Takuchi, we can get only one response in case two output response required.
Again, you need to run more another experiment with the same condition. So at least in Taguchi, at least what we are advising, at least minimum 3 responses required actually. Minimum 3 response are for each condition. So that you can have variation of 3 responses. For example, each one response is 10, another response is 11, another response is 14. So 10 and 11 is closer and 14 is away from your closer one. So you take only 2. Suppose if you are run 2 experiments at a time for each condition, one is 10, one is 14. Which one is good? We don't know. Maybe 14, maybe 10. We don't know. Unless you do some more experiment, then only if it is closer to either 10 or 14, then you take very closer values. That is better. That will give more accurate result. I think you got my point.
Yes, sir, I think. Sir, another question. How to get mostly contributing parameter in weld quality by machine learning tools?
Yeah, you can use random forest method. You can use supervised learning. You can use regression analysis. From that, you can have what I mean to say is it requires more data. If you have more data, you can get a better solution. If you less data, you can get solution, but it may not be nearer to your actual one. That is important. That's why suppose if costly experimental procedure like additive manufacturing, you can run the experiment using Taguchi method. From that, you can develop the regression equation. From that, you can get the more setup data. So that entire data is valid for that kind of system or kind of additive manufacturing facility. Then you can use machine learning using that data to get the better one. In Taguchi, there are some disadvantage. Suppose if you take only 10 and 15 and 20, these are 3 levels. Only you are getting the either minimum or maximum value at the levels only, not in between the 10 to 20 or 20 to 30. That is the drawbacks. So once you overcome the drawback using regression again, using the Taguchi data, you can develop the regression. That's all.
Still any doubts, Amma? Participants, you can ask. You can unmute yourself and ask, Amma. Participants.
No doubt, sir. All is clear.
Okay.
Good morning, sir. Good morning, sir.
Yeah.
Good morning.
My doubt is what are the different optimization technique used in welding? Because which one is suitable for the welding?
No, any optimization technique you can apply in any field, not only welding. Only see that you can see how you are generating the data is important. Suppose welding, for example, if you take turning and welding, for example, suppose I
Yes.
want to turn a particular machine using giving some speed and feed and depth upward, then I can get output as a surface finish, for example. So within fraction of time, you can get this output response. For the welding, suppose you weld some material, then you need to section it and you need to go for microstructure analysis and then testing, so that it takes a lot of time to get your response, not immediately. That's why in welding you can run as number of experiments as much as less.
And sir, another one, that design of experiment we are using most of the time. And for that one, we can also use the concept of machine learning and.
Yeah, you can use. That's what I am said. No, first initially you can use Taguchi. From the Taguchi you can develop the equation, regression equation.
Yes.
From that equation, then you can get more number of data. By giving certain input, then you can get automatically output. So that you can generate lot of data using these two techniques. One is Taguchi, one is regression. Why you are using Taguchi? Because limited number of experiments. For certain cases, for an experimental cost is very high, then you need not run for more than 15 or 20 experiments, then you can use Taguchi method.
Yes, sir. Thank you, sir.
Fine.
Still any doubts, Amma? Participants? You can unmute and talk, Amma. Still any doubts? Still any doubts, you can ask, Amma, participants. Okay then. Okay then, sir, I will conclude this session, sir.
Fine. Thank you.
Okay. Okay then. Dr. A. Kumar, sir, in his presentation has given the in-depth information about RSW monitoring and control systems, thermal expansion, quality assurance, need of optimization conditions, nugget formation and growth, and steps involved in machine learning algorithm. Other than this, difference between good wells and the poor wells. Thank you very much, sir, for accepting our invitation and delivering an excellent lecture. Thank you very much, sir.
Yeah. Thank you. Thank you.
Thank
Anand.
you. Thank you, sir. Thank you.
Yeah. I can leave the meeting.
Yes, sir. Yes, sir.
Thank you.
Thank you, sir.
Thank you.
And the next session begins at 2 o'clock, Amma. Afternoon session begins at 2 o'clock. Okay.
Sir,
So-
can you please let us know when the test will begin
The
after
test,
this session?
after the afternoon session, the test link will be posted in the FDP group. And
Okay.
and overall feedback link will be posted in FDP group.
Okay, sir. Thank you for at after 4 p.m. No, sir.
After afternoon session completed only, it will be around 4 p.m. or 3:30 p.m.
Okay, sir. After 3:30 will be fine. Thank
Sir,
you.
what is the maximum time you are giving for the test, sir?
Actually, it is 1 hour, madam. 1 hour. For the
Well,
test.
if we started the exam, then from that to 1 hour, or after posting your link, it will be 1 hour.
No. When you will start your exam, from there it will be 1 hour.
Okay, sir. Because at that time we'll be in travel. That's
Yes,
why I'm
yes,
asking.
madam. Yes, madam. From
Yes, sir.
there we will
Yeah.
start. From there it will be 1 hour.
Okay, sir. At
That will
till
fine.
what time that link will be activated, sir? That means by night or by tomorrow
No, madam.
morning?
No, madam. You can
Yeah.
complete in 1-2 days. It may be
1-2 days. Okay.
no problem, madam.
Okay, sir. Thank you so much,
Hello.
sir.
Sir,
Hello,
1
sir.
hour test means, see, 1 hour test means, is it subjective type or objective type or combined?
It is multiple objective, sir. Only multiple objective.
Okay. So means test can be given. What is the between 3 to 4 or 1 hour or any within 1 or 2 days
At
we can do it.
in 1 or 2 days at any convenient time, you can give your test, sir.
Okay, thank you.
Sir,
Thank
one
you.
more question. Till when will we get the certificates?
Madam, it will take, I think, after completion of the FDP, 1 week, madam. In next week, you will get it.
Sir, are you
Okay. So
providing
you will mail it
certificates
to
to
us, sir?
everyone? Only those who passed the test only you are providing the certificates. Is there any mark
Yes,
for the
madam.
test?
We are not yet decided, madam, but
Okay.
we will send the certificates in the next by next weekend, madam.
Okay, sir.
Okay.